Welcome to our second podcast. This one's going to be on battery energy storage system remote monitoring. With me, I have Claudius Jehle from Volytica. I hope I'm saying that correctly. And we'll let just tell us a little bit about how Volytica got started and what gap in the BSS ecosystem you were trying to fill.
Yeah, thanks, John. Thanks for the kind words. Thanks for the introduction. So it's Volytica, or Volytica, as the Americans would rather say. And I'll, in a minute, tell you why the name came about. And until today, I don't think it's the best pick, but there is a story to it. So my name is Claudius. I am one of the two founders of Volytica Diagnostics, by education a mechanical engineer. But right after my studies, I had the opportunity to start a PhD thesis in a small research institute in the far east of Germany, in Dresden. And this was about in-life diagnostics of lithium-ion battery health in electric vehicles. This is 13 or 12 and a half years ago, and it seemed super exotic to me, super interesting. Electric vehicles powered by batteries, what is that? Come on, I gotta do it. And I moved into this city, and naive as I was, started digging into the topic of how can we learn something about this crazily expensive, complex component once it left the factory. Because until today, there is a lot of energy put into modeling of lithium-ion batteries in the lab during the design phase, when it is constructed, designed, built, programmed. But once these components, and this is until today the same story, leave the production site, it's unclear whether all those modeling was actually correct. Because bear in mind, the technology that is typically brought to the road or into BSS systems is 2-3 years old, but it's supposed to live for 10, 15, 20 years. So not even the manufacturers of the cells have tested those cells for the time that are supposed to live. So yeah, I started this PhD thesis to extract from readily available sensor data that every battery system generates, my computer mouse, my laptop, a BSS system, an electric bus, to find models that can convert standard signals into something meaningful, to convert voltage, current, temperature into residual capacity indicators for safety critical anomalies or any other indicators for performance risks, to find out what measures one can do to extend lifetime, all from this data that was there back then and is there until today. And this was in a research context, but we quickly found out that there is an interest from many stakeholders, from the manufacturers, from the system integrators, from the owners, from financiers, from insurance companies, from politics. And quite quickly we realized that shouldn't be put in a jail in a research institute, but for it to work, it must be put into a commercial context. And a few years after we started this research, we founded Volytica Diagnostics. This was now 5.5 years ago.
Awesome. When I try to describe it, I say that those out there that are using heat detection to try and detect thermal runaway in a battery a few minutes after it starts, and then there are those that are trying to use off-gassing to try and detect it seconds after it starts. And when I was talking to Boris from your company, he was saying that we want to detect it weeks and months before it starts. And that's kind of the difference between your remote monitoring and maybe some of the other that we've seen. Tell us how your platform differs from typical BMS and SCADA. What's the difference between just reporting what the BMS system's saying?
I would not say there is a difference in that sense. You cannot compare us. There is not either BMS or SCADA or us. It is a layered thing. The first frontier is the BMS. There has to be a BMS. Someone recently said the BMS is like the pilot in an airplane's cockpit. And we are the tower, the air traffic control in a way. So there is no either or, it is an and. This and this, a layered approach. Why do we have control rooms for nuclear power plants? We'll have control rooms for BSS systems as well, and these control rooms need software. And plainly put, that's us. We're not fancy. It's often said like advanced analytics. Okay, it's advanced. Of course, we have put a lot of energy, sweat, tears, blood, money into it, but in the end, it's a natural thing to have electronics and intelligence right next to the cells. Then you have to have something that transmits and manages the data. You could say that this is the job of the SCADA system. And then you have to have something that makes sense out of it. And you could also say that this is a job of the BMS, and it partially is. But when it comes to comparing modules or racks or containers to each other, you already need some form of connectivity. So this is where the BMS stops. And also when you want to look at long-term trend detection, BMS typically doesn't have this long memory and also not the computational power. Then you are already in a centralized setup. And what we at Volytica, compared to some other players in the market, are known for is that, so there's the BMS, there's a SCADA system, sometimes there is an energy management system, and then there is not separately as a separate pillar us, but we're integrating using web APIs into the SCADA system so that the operators have everything in one spot. So I circumvented your question a bit. There is no difference in that sense. This is a serial thing, another parallel. We are just a logical step in, and I think, like Outlook, anticipating a bit the end of our session today, at the moment we are looked at as an exotic animal. Why do you need that? There's a BMS. In 2 or 3 years, everyone will have understood, hopefully, but I'm convinced that it's a logical thing to have.
I think you're right. I think our viewers who are familiar with the gas turbine industry already see that the OEMs of the gas turbines offer a similar remote monitoring service where, you know, the operators at the site are busy running the plant, trying to meet the grid demands, but don't have the time or the luxury to analyze the data in the depth that the remote monitoring center does. But all the insurance companies that we as brokers deal with, they very happy to see that there's a remote monitoring service for the gas turbines. And I think that when they understand that the discussion about battery energy storage system spacing is just one little piece of the risk management, and that we've got so many other layers of protection that we can look towards, and that they'll potentially give some credit to you guys are doing, and not just credit, but emphasize the density of it.
It's almost, we add in a CapEx sense 0 point something% of cost over a 10-year period. Nobody can tell me that the added cost of our system can destroy a business case. Oh, we added 0% of cost. This destroys the business case. I don't believe that. It can end up in significant amounts of 5 or 6 digits annually for large plants, fair enough. But in a total cost of ownership view, for plants that cost billions, we don't destroy a business case. And because you brought up the gas turbines, imagine an asset doesn't just have a, pardon my French, big ass single gas turbine, but a million small ones. And this is one asset with one insurance policy. And then you need someone that looks at this at the same time at the analogy obviously is cells or modules or whatever you have. You cannot, as a person, look at a screen with a million voltage readings and identify, oh, this is the critical one now. So you need automation in one form or another. And then I think there also comes a political dimension to it. I think in English you say you cannot have the fox keep the geese.
Okay.
It's not the job of the OEMs alone to do the monitoring and to provide all the risk and warranty monitoring to the owners, operators, and financiers. It's not in their best interest to have these systems running as long as possible. Obviously not. Planned obsolescence or obsolescence, I don't know how to pronounce it in German, so obsolescence, yeah. So a battery is considered dead, end of life when the warranty ends. That doesn't make sense. It's the end of the warranty period. The system was designed to be good until that point and only fail after. But the whole industry is considering the end of the warranty period when the state of health reaches an arbitrary threshold, considers the thing to be dead, end of life, but we're mixing up things. So the OEMs have a legitimate interest, in my opinion, we're capitalists, to not tell the full truth to the people buying the batteries. And I'm not blaming anyone, that's a logical thing. So there must be an independent party.
Sure. Well, what kind of data are you guys analyzing? Cell voltages, temperatures, internal resistance, state of health trends? What are you actually looking at?
Input is the holy trinity of sensors in the batteries. This is voltage, current, and temperature. Everything else is a calculated, estimated, or derived thing. You mentioned internal resistance. This is an output of these three inputs. So we're looking at internal resistance. Internal resistance the deviation of internal resistance between modules, racks, cells can indicate problems, weeks. Okay, you said months, something. It's rather days or weeks before something happens. State of health, you mentioned state of SOH or state of health. It's also an output. Sometimes the BMS tries to estimate state of health. It's a super complex calculation behind. It's a super challenging thing. So one of the reasons BMS alone isn't, in our opinion, or we know it, we see it every day, sufficient to just look at state of health. Oddly, state of health, the word alone seems to suggest that by looking at this value, you get a sense for the health of a system. It's just the residual capacity that the state of health, for reasons unknown, refer to. So yes, we are calculating state of health. This is the residual capacity of the systems compared to the initial capacity. And again, if you see modules deviate from each other, that's a good indicator that something's going south. We're looking at another long list of KPIs that indicate the quality of a battery. I'm always comparing it a bit to a blood sample. You go to your doctors, they take a bit of blood from you, and then you don't get a printout with a smiley, you get a list of KPIs, and then you get a ruler bar for every of them. And the same goes for an electrochemical system like a battery. We're also electrochemical systems. You cannot describe quality by just one parameter. So we're looking at a lot of things, a lot of KPIs that some of them are standard, some of them we developed over the past 10 or 15 years. But in the end, the outcome that we present to our clients are supposed to be as simple as a good doctor would read out the blood test to you. So we calculate the full list, but in the end we tell you there is a critical safety incident, do this and that. And if you don't, this will happen or might happen.
Okay. Do you guys use fleet level benchmarking?
We always, like, one of the a big part of the magic behind is that a centralized monitoring platform like ours is able to compare different units and units of the same type. So absolutely, this is one of the strongest arguments of doing something like what we do.
Awesome. How about this is what I call it, but do you have any case studies where you've actually did an issue before it went wrong?
We have many. Our biggest client is Enel, Italian utility, but also very active in the United States. We have been monitoring a huge fleet for them since the beginning of last year. And very quickly already, we identified in many plants in the United States, but also in Europe, problems that were then fixed before something happened. And that's the reason we're extending the contract now, not only in time, but also in the regions. I just told you that the final output that we're generating is not necessarily this complex list of KPIs, but rather an indication: is there a safety risk? Yes, no. Is there a risk of performance limitations? Yes, no. The tool that generates this nice looking output, we call it the VDX Sentry. VDX is Volytica Diagnostics abbreviation. So VDX Sentry is the Volytica Diagnostics Sentry. It's a bot that automatically does all these cross-checks, cross-correlations, looking at the KPIs, looking at trends, something that a battery engineer like I would do if I didn't have to sleep. And this Sentry, when it issues a diagnosis saying in this plant, in this part of the world, in container number 7, in rack number 8, there is an indication for a safety problem. When such an event is issued, the whole company gets a ping. And we're all looking at what's happening. And there are currently, just to give you a feeling, something like 5 or 6 cases ongoing where we are witnessing developing trend of malfunction, risk of worsening performance problems. And in one case, there is a risk of a fire, safety incident. Of course, we're in close contact with the clients that are the source of those incidents, but just to give you a feeling, there is always something going on. Not all of the problems automatically will lead to a thermal runaway. That's the small minority. But there are also normal failures that eventually could result in an insurance case. And 80% of the things we detect are not immediately safety critical. I have case studies. I can open some in parallel, but I can really tell you that
Sure, you can
alone,
share this. A little twist on saves is preventative predictive maintenance. A lot of times in industry, we have a preventative maintenance schedule that says every quarter we'll go clean the terminals, or every 6 months we'll check the air filters for the ventilation system. And predictive maintenance program, since it's a little bit smarter, it can figure out, well, the dust levels are lower here on this site, and we don't have to go out every 6 months. We can get away with every year, and we can actually save money in some of the maintenance that we're doing. Can your system help both directions, increase the frequency and decrease the frequency of maintenance to be more applicable to the actual conditions that equipment is running in?
batteries are considered maintenance-free. They are not, but they are marketed and promoted as being maintenance-free. Yeah, of course, sometimes you have to clean, as you said, terminals or whatever. But I think the main reason to use our tool is to prevent, to spot something before it happens and then act accordingly, and rather not decrease the time between going into a container and doing something, because you don't have to do active maintenance with a battery. Although you might have heard about balancing. Do you know what balancing is?
I'm a protection engineer, so it's a little bit of a black box, but I've heard of it.
In essence, a container is like a clockwork. We, including me, consider it as a battery, but it consists of tens of thousands of cells that have to work for 20 years, absolutely identical. It's a miracle in a way. The BMS primary job is to take care of that. But inhomogeneous temperature control, and I'm not speaking about 10 degrees difference, subtle differences, also quality differences, very little ones from the get-go, lead to different rates of degradation and performance of those cells. And that leads to if you don't do maintenance, that a creeping difference of state of charge filling level of those thousands of cells in a container will happen. That means that if you don't, and no other system doesn't do what's called balancing, you will end up in a situation where now all the 1,000 cells are 100% full, or let's say 50% full. You keep operating them, and for said reasons, after a week or so, they don't end up at the same state of charge anymore, which they should, because they are supposed to be identical. Some of them will not have 50, some of them have 52, and others have 48. And some of them might have 40. Now, the thing is, that's a bit of a detour now, but maybe interesting for some of the listeners. The thing is, if you have 1,000 cells in a container and they do not have the same state of charge anymore, but the container logically reports a representative state of charge to the energy management system saying, I'm 50% full, footnote, on average. But one of the cells is just 40% full. And you start discharging the whole system by 50% because this is the value that's told to the energy management system or to the trading system. The cell that is already only 40% full will be empty first, logically, because they all get discharged at the same rate.
Right.
And this will stop discharging the whole container just because one of the 1,000 cells is already empty, but 999 are still 10% full.
Gotcha.
And then you'll pay a lot of penalties to the grid operator. So you have to do balancing, and you cannot, this balancing is supposed to be automatically done by the BMS, but sometimes the BMS can't. Now we're going very deep and I'm gonna stop here. But the operator of the plant has to take care that the BMS comes into a position of frequently doing this rebalancing, charging, discharging all the cells to all keep them at the same level so that the one representative value of state of charge that is delivered to the outside world is actually really representative of what's going on the inside. And that is what is the main maintenance thing that has to be done. So you asked me what type of, is it preventive, predictive maintenance? Of course, one of the main strengths, what we do is we give the operator a good feeling of the state of balance, a better feeling than the BMS can. It's supposed to be the job of the BMS, but for various reasons, it's very difficult for the BMS to be very accurate on it. And if you have a lot of data and you can compare assets to each other, you call it fleet management or fleet comparison. A centralized monitoring like us integrated into a SCADA system can give a way better estimate and can make way better suggestions to an operator, to an O&M provider to say, okay, this is disbalanced, you have to rebalance. If you don't, you will run into the risk of penalties.
Gotcha. Let's a little bit and talk about how your data is being used by the insurance community, the brokers, the underwriters, risk engineers.
First thing, it's only starting. I told you at the beginning, it's, in my opinion, it's hand in glove. We are witnessing since 18-ish months, I would say, or a year, increased interests from both our direct clients, typically the owners or operators of the assets, that are interested in getting a stronger or cheaper, whatever, insurance cover when they invest into a solution like us with a logic that I can follow. The insurance industry has to honor our efforts. Why do we not get it? And this is one of the pull reasons, I would say, why the insurance industry is waking up and listening to the topic. And then there are insurers that are very innovative and that have a history in such solutions like ours in other technologies, and they actively look for risk mitigating tools. So we're currently in contact with at least, I would say, 8 to 10 of the larger global insurance companies to find scalable arrangements. What I mean by scalable, I mean on a project basis, all of the company like Volytica or competitors have contacts with the insurance industry where a client gets a discount, but to find a setup that is replicable without heavily involving for every case an underwriter and person from our end, this is currently, I think, what's our main concern. And part of that logically is to standardize or put into standard wording what we're actually doing. Because it will not work that an insurer says Volytica and no one else. Of course, I would find that great, but I'm not naive. It has to be technology agnostic, and the insurance industry should say something like, you have to have a system like, and now comes the question. At the moment, the solutions like ours and of our competitors are not really comparable enough. Yeah, we do safety monitoring, but what actually? Some look more at internal resistance. We look more at capacity fade. We have other tools that we don't want to disclose too much. And I think this is the main thing that we're working on with insurers together. But as I mentioned, on a project basis, the setups are very simple. Just recently with a German utility company, they're working with a major German insurance company on their PV portfolio and now also on their BESS portfolio. The insurer said, if you have a system like Volytica, you'll get a 50% discount, or you'll get 2 offers. One is this and the other is 50% cheaper if you have Volytica installed. And this covers almost 50% of the costs that the client has with us. So it's a no-brainer for them.
Okay. Well, a lot of the viewers of my channel are risk engineers, and they know what they're looking for really, as far as a report or the format of a fire pump test results. What would they be looking for? And what should underwriters look for from Volytica? What kind of visualizations do you guys provide that would they could tell the health of the batteries?
One of the things when I said we're currently working with insurers on scalable insurance setups is that we are designing a standard reporting. We have it already, a report that summarizes the status of a plant quarterly or annually, whatever the insurer wants, in easy enough terms for in-life monitoring, but also I would probably call it certificate, although this sounds very official, a document that proves before the commercial operation date of a plant which features are enabled from our service at the plant, so that the risk engineer and the underwriter can then say, okay, great. So you bought Volytica and you bought the right features that are actually mitigating your risk, and you are obliged to act accordingly, which is also written on that document. As if we say, okay, there's something bad, then please act accordingly. We have documents that both before the COD and in life prove towards the risk engineers and the underwriters what's going on.
One of the things that the underwriters are very concerned with is maximum foreseeable loss or probable maximum loss, and they model that. They're always worried about business interruption losses because they typically exceed the property damage loss. How can your technology support better modeling of MFLs, PMLs, and BI?
Yeah, particularly BI is a thing with BESS, right? Because for a PV module, or a PV farm or a wind farm, it's much easier to assess what actually the loss is going to be. But with a BESS system that is so versatile, it's much harder. But yeah, this is actually one of the things that we're currently also working on, particularly BI for the business interruption, to get to a better modeling of the risks and the financial risk associated to it. Also because of the centralized data gathering, as I said before, if all the information would be locked in the containers themselves, not provided in a form that you statistically can analyze it, then you cannot do modeling on the statistical risks. So again, because we have all the information centralized of different kinds of technologies in the lithium-ion technology family over long periods of time, we can help model. And currently we're doing exactly that with a Chinese OEM, where the OEM is interested in not just selling the BESS, but with the BESS, a BI-like insurance. With them, we're modeling, proving independently that their technology is better than others, because we are an independent player that can prove that can do this analysis and say, okay, the risk of a business interruption is lower if you use this technology, and particularly if we are installed, then you can even reduce the last risk here. It all evolves around data and to speed up data gathering, and not just a lot of data, but the gist of the data, to get to the simple color-coded red, amber, green.
The RAG charts.
Exactly, RAG
Yeah.
charts.
Well, if you were to get out your crystal ball, where do you see predictive diagnostics going in the next 3 to 5 years?
It will become a commodity. As I said at the beginning, it will not be something where people think yes or no. It will become standard. That also means that prices might drop even further. I could stop here because I think this is what's going to happen. There's a lot of other things going to happen as well, and I see, looking into the crystal ball, other things happening as well. But the most important thing is that it will not be a if or not decision, but rather which solution. I think also the OEMs will continue to try to push their own condition monitoring, but I don't think this will fly, because first of all, that's not their interest, the fox and the geese example. But the next thing is that many of our clients want a heterogeneous portfolio. They do not want a single OEM. That would lead that their asset management teams and O&M teams would need to use a zoo or jungle of different OEM tools. So I think it will all go into an independent, centralized form. That's what I think is going to happen.
Well, are you guys working with any OEMs or asset managers that this capability at commissioning?
We didn't speak about that yet, but commissioning is a very hot topic. We are one of the few providers of technology that supports already during FAT, factory acceptance test. So we have partners that many of you guys might know from the PV industry, Voltaics and others, that perform tests of PV, but also BESS modules in the factories. And we developed with Voltaics a solution that very, very quickly analyzes cell quality of the racks and containers before they're being shipped. So this is one of our best-selling products at the moment, because the typical FAT, factory acceptance test of a BESS module at the moment, before we came in, doesn't deserve the name. They're checking visually on a sample basis whether the cables are there and the coating on the containers, whether they are thick enough. But the cell quality and whether the HVAC system is not just turning on, but homogeneously cooling or sometimes heating the systems is not being checked. Although it could be so simple and cheap. So commissioning support starting in the factory is one of the most important things that we think should be done. That's an absolute must. And also then commissioning on site, site acceptance test, also super important. Bear in mind, a battery is degrading when it's not being used. Sometimes a battery is degrading far more when it's not being used than when it's being used. And sometimes the containers are being shipped and then they stand in the sun for 1.5 years. They are degrading a lot more than what they would have degraded would they have been used over those, I don't know, months.
Wow.
So you must do a one-off assessment before this thing goes operational. But you can also think further. End of warranty. Some people say end of life. It's end of warranty. It's starting, the questions around end of warranty assessment, one-off assessment and reporting are increasing. We recently conducted the first one in Germany, where the plant after 12 years is at the end of the warranty period and everyone is scratching their head and saying, okay, thing seems to be operating. What do we do? Landfill site, buy a new one. The OEM already has an offer on the table to buy a new one, but it seems to be working. How good is it still? Or can I sell it? What if I sell a part of my portfolio to someone? The buyer has a legitimate interest to know what's going on. And FAT, SAT, or whatever acceptance test, end of warranty testing, one-off reporting, big thing, big thing.
So you guys are looking at battery systems, and we've talked about thermal runaway. Are there any other challenges that you would say remain for the BESS risk that operators and risk engineers should be thinking about?
I would have loved also to show the examples, which in the meantime I found. In the end, I mean, I mentioned only a fraction of anomalies end up in a thermal runaway. There are multiple reasons for a thermal runaway. By the way, thermal runaway is just the effect that something runs away thermally. The reasons could be an internal cell defect. The reasons could be someone putting a cigarette butt into a rack, whatever ignition source there may be. And by the way, that's why I'm off-gassing sensors and heat detection sensors, you mentioned it yourself, they detect the thing closely before or after the fact, are not good to identify root causes that are early indicators. But your question was a bit different. Are there other risks? Of course, thermal runaway is a big risk. Hard to contain, multiple reasons, internal cell defects, wrong operation, problems with the auxiliaries, cabling, sensor issues, big thing, sensor issues, sensor cable falling off, BMS things, temperature is good, but actually temperature way too high, but sensor problem. Other risks are obviously the less fanciful, the less colorful problems where a system just breaks down and doesn't work anymore, which is more frequent thing. And then it also ends up on the table of the insurers. And then the question is, what's the problem? Is it a balancing problem? I explained at length. Is it a problem of the software? And also here, root cause analysis can help every party to fight on eye level.
Gotcha. As we wind up the end of this segment, then is there anything else you wanted to talk to the viewers about?
Well, my message is always, and that's the vision of the company, the lithium-ion technology is one of the most complex, non-Western, most expensive technologies that has been there, and it's pushed into the industry with a insane speed. We are not using this technology to the true potential. There are logical reasons to it. The speed at which this technology is coming at us is much higher than we can educate people in the universities and academia and on site to have the experience to deal with this technology. So there is a huge lack of expertise and experts, but the best are there. And they're complex and expensive. And this is a problem. So there is no way around centralized monitoring, automated data analysis. There is no way around. We cannot manage. In the European Union, there is an estimation that 100,000 jobs are vacant because battery expertise, battery expert jobs, because the people are just not there. Where should they come from? And
Right.
even if they just drop out of university, that's not what you're looking for. You look for people with 5 or 10 years of experience. So
Yeah,
you
and we
have
haven't
to
had
have,
the industry around that long.
yes. And it
So,
is a truly Asian technology.
yeah,
Credits to them.
and our viewers get a hold of you or learn more about Volytica.
Sure. So one obvious thing is they just visit our website, www.volytica.com, or they visit our LinkedIn profile,
Okay.
or they just send me an email. It's claudius.jehle@volytica.com. Very simple. I mean, we're easy to approach. We're a comparably small team. And you can also freely reach out via LinkedIn to me or to my colleagues or to Boris. You mentioned him earlier. Boris is our business developer for the finance and insurance industry. He has a background at Marsh and other institutes, so he speaks your language potentially better than I do. So I suggest you go by our website or LinkedIn profile, or
Okay.
just reach out directly to me.
Awesome.